When you've got the product of two or more binomial expansions, sometimes you can use the difference of two squares to actually simplify them. Now, this is not something you would immediately jump to because often our binomial expansions are using powers of much more than 2. And up until the end of year 10, we tend to be locked into thinking that the difference of two squares is only involving squares or powers of 2. So, quick revision, we know what the difference of two squares looks like, and this should be something that's really familiar to you. We also know this little index law, which is that if we're multiplying two numbers and then raising them to a power, we can raise them separately to that power and then multiply them. The order doesn't matter. So knowing both of those two things, if we're faced with something that's in this sort of shape, where we've got what looks like this, but both the parts are actually both raised to some power, let's call it n for now, we could simplify that by saying, well, instead of, if they're both raised to the same power, and it has to be the same power, it's just like undoing this part, isn't it? To say, well, let's multiply the two things together first, then raise them to the power collectively. And that's all I've done here is I've multiplied these two parts in brackets by each other, and then together they're both raised to that same power of n. Now we can clearly and easily see that we've got the difference of two squares here. And so we've got this thing squared minus this thing squared, all raised to that power n. Now, n could be anything. N could be, say, 30. And what you've got to find is that you can then simplify a question that looks like this and get it looking instead like that, a lot simpler. So let's now simplify a couple so that we can see how it's done. This first one, we can clearly and easily see that both the terms in the binomial are exactly the same, except that one is plus and one is minus, and importantly, both of the powers are exactly the same. So here, we could do that step in our head, the one that says, let's multiply these two things together and raise the whole thing to the power of 5. In other words, make it look like this. And now this part that we have in the middle here is the difference of two squares. It's x squared minus 2 over x squared, which of course is minus 4 over x squared. And that whole thing will be raised to the power of 5. Now this next example is a little bit different. Can you spot why? Yeah, we've got two different powers here. So the first thing to do is to actually just tidy it up a little bit and make the powers the same. So here we can say that this is x plus 1 over x. We have one lot of it. You can put to the power of 1 if you want, or just leave that out. And then we have x plus 1 over x to the power of 16. Now that whole part there is equivalent to that, isn't it? Because the bases are the same, and I add the indices. 1 plus 16 is 17. And now I can put this second part in here. Now, these two parts can talk to each other. I've got the difference of two squares, and this bit can just hang out the front. So I'm going to leave this bit on its own, x plus 1 over x. And then this part here is going to be x squared minus 1 over x squared all to the power of 16. Now, how is this useful? Well, if we had a question like this and it said, find the term that's independent of x in this expansion, or maybe find the term in x squared, or whatever you like, then this one will be probably a little bit easier to work with because we can more clearly and easily see what's going to happen. We've got this part here is raised to the power of 1. So we've really just got two terms. They're nice and simple, and we've just got one bit that's complicated. Whereas here, having something to the power of 17, something else to the power of 16, much more complicated and tricky to work with. So now let's have a go at finding the term in x from this expansion here. We'll write it up on the board again so that we've got a bit of space. So find the term in x in this expansion. Well, we've already done the first line. We've tidied it up and made it a little bit more simple. This should make our life easier because if we're finding the term in x, then we're going to get that by either multiplying the x in this first part by the constant in the expansion, or this 1 over x term in the first part by a term in x squared in the expansion. Because 1 over x multiplied by something x squared is also going to give us a term of x, and then we need to add the two together. Now these two terms are just simple and straightforward, but it would be really handy to have a general term, in other words a little formula or recipe to find any one term that we want here, so that we can find it quickly and easily. Now because there's the same pronumeral in both parts, it makes sense to follow our little recipe and then tidy it up with our index laws. So we have n choose r, in this case 16 choose r. Then we have the first part, x squared, raised to 16 minus r. And we have the second part. Now you'll notice that the second part is 1 over x squared, and it makes sense to break that up. That's the same thing as minus 1 times 1 over x squared. And the reason we'd like to break it up is because then we can see clearly whether we've raised our negative 1 to an odd or an even power will tell us whether this term is positive or negative, and it just makes it a little bit more straightforward. So instead of putting minus 1 over x squared to the power of r, I've just done the minus 1 to the r, and then I've done the 1 over x squared also to the power of r. Now I can tidy up, and I can see I've got 16 choose r. I've got x to the power of 32 minus 2r, but I've also got x to the power of 2r on the bottom here, because x squared to the power of r is x to the 2r. So I actually need to do 32 minus 2r for this part, minus another 2r. So I can actually do that in my head and say, actually that's minus 4r. And then I've got my minus 1 raised to a power. Now, what x's are we looking for? We want x to the power of nothing, because we want the constant term, and we want x to the power of 2, because x squared times 1 over x, that will give us our term in x. So they're the two that we want. So if we want x to be to the power of 0, we need to let 32 minus 4r equal 0, and we need to let 32 minus 4r equal 2, and solve those equations. So in this case, r will need to be 8, and in this case, r will need to be, what's that, 7.5. Now, whoa, hold the phone. R can't be 7.5. Why not? Well, r has to be an integer. It's an actual integer term in the expansion in every single one of these terms. So if you get a number here that is not an integer, then you know that it actually can't be that. Now, why not? Well, when you expand this part out, you never get a term in x squared. Why don't you? Well, the first term, if you think about what the first term would be 16 choose 0, and then it would be x squared to the power of 16, which is x to the power of 32. The second term would be 16 choose 1, etc., and then we've got x squared to the power of, what have we got, 15, and then we'd have 1 over x squared to the power of 1. So here we've got x to the 30 over x to the 2. This term has got x to the power of 28. This term has x to the power of 32. And if you keep going, what you're going to find is that in this expansion, the powers of x go down by 4s. The next one's going to be x to the power of 24, etc., etc. Now, there's never going to be an x squared. So we've gone looking for something that wasn't there. And that's perfectly fine, but you've got to be prepared to look for something and then say, oh, no, it was really smart of me to check for it, but it doesn't exist. So we know now that all we really need to do is, we can cross that out if we like, and instead of rubbing it out, if you've done this on your exam or on your workbook, just put a line through it and say doesn't exist or something like that. So it shows that you've gone looking for something and you've acknowledged it's not there. So we want r to be 8. And all we're going to find in this expansion that's going to help us is a constant. And all we'll need to do then is multiply it by x. So the constant term is when r equals 8. So it's going to be 16 choose 8 x to the power of, now when r is 8, we've got a constant, so it's x to the power of 0, and that's a constant. And then we're going to have minus 1 to the power of 8, and we know that when we're raising negative 1 to an even number, then this is just going to be 1. So we've got 6 choose 8 times 1, and then we're going to multiply that by x. So all we really need to put into our calculator is the 16 choose 8 part, and we get this. And that will be the term in x from this whole expansion.